Well, if we start this problem by plugging in 0 for x, here's what we're going to get. We're going to get the square root of 0 plus 5, which is 5, minus root 5, all over 0. And root 5 minus root 5 is 0 over 0. And this is one of those cases where you might be tempted to put 0 as the limit, or maybe you see the 0 in the denominator and want to say it's undefined, and neither of those answers would be correct. So what we have to do is we need to rationalize the numerator. So we're going to take this numerator and multiply by exactly the same thing, except we change that negative sign to a positive right there. And we do the same in the denominator. That's going to be square root of x plus 5 plus root 5. And now we're going to distribute. So you can see on the top we have an a minus b times an a plus b. So that's going to just give us the same limit as x goes to 0 of x plus 5 minus 5. And in the bottom we're just going to leave it. We're not going to distribute out this whole situation, x plus 5 plus root 5. We're going to leave it like that. And the reason that we do that is because right now we can see that 5 and negative 5 cancel, and we're actually left with this x over x. So this cancels with this, and we're left with 1 divided by all of that right there. So then we've got the limit as x goes to 0 of 1 divided by, and if you see this x right here, we plug in 0 there, then we're just going to get root 5 plus root 5, and that is the same as, the best way to write this is 1 over 2 square roots of 5. So a very similar question here. If we plug in the negative 3, we're going to end up with one of those 0 over 0 situations, and we don't like that, so we're going to rationalize the numerator. In other words, we're going to take this and multiply by the same thing, except we're going to multiply by plus 2. And the same thing on the bottom, square root of 1 minus x plus 2. So then, let's see what happens. X goes to negative 3. Well, on the top we've got an a plus b, an a minus b times a plus b, which is going to give us 1 minus x minus 2 all over, and I'm going to leave this as x plus 3 times by all of that part. So that's going to be the 1 minus x plus 2. Okay, what now? Well, that's going to be the limit as x goes to negative 3, and this is the same as negative x, let's see here, negative x minus 1. Okay, I'm embarrassed to say this, but I made a mistake, didn't I? Because if we look at this here, let me just switch colours so that you can see what's going on. This is our a minus b, and this is our a plus b, and when we multiply those two together we get a squared minus b squared, and the a squared would give us 1 minus x minus, and the b squared, well, this right here is b, so b squared would be 4. So that means I've got a little bit of a correction to do here. That means that this isn't minus 2, this is minus 4. And when we simplify that, we actually get negative x minus not 1, we get negative x minus 3 over x plus 3, and the square root of that. And you may be a bit concerned now, because normally when we do this stage we can get rid of something, and that right there is not the same as that right there, although just like we did in class, we can actually factor out a negative, and that will leave us with the limit as x goes to negative 3 of negative parentheses, and then it's x plus 3 divided by and now you can see that's the same as what we have on the bottom, and that's going to help us out a lot. So now these are going to simplify to just 1, and now we can just plug in our limits. So now it's going to be the limit as x goes to -3 of 1 over square root of 1 minus x plus 2. So when we plug that in, we actually get 1 over the square root of 1 minus -3 plus 2, which is the same as 1 over, well, that's the square root of 4 plus 2. I'm really showing all my steps here so that you can see how this is coming along. And square root of 4 is 2, so that's just 1 over 4. There's your limit. As long as you remember how to factor here, then this question is going to seem much easier. And I'm just going to do a quick factoring over to the side here. So that's the limit as x goes to -2. Now you can use the go fish method, which I think is the best, but I'm going to use the guess and check method, which in this case is not very hard to do. And there is a big clue. Normally with limit questions like this, one of these factors is going to be the same as this. In fact, almost always that's going to happen. So I'm going to say 2x and x, and then because I've got this 2 down here, I'm just going to safely say that's probably going to be a 2. This is going to be a -1, and you can always check to make sure that that works. Now we can see they divide, and we're left with the limit as x goes to -2 of 2x minus 1, and if we just plug that in, we are going to get -4, -5, right? Just like that. In order to do this question, we need to remember our magic formula, which I'm not going to give you on the test, but you're going to remember that the derivative, or f prime of x, as we might call it, is equal to f of x plus h, which basically means we take this right here, our f of x, and every time we see x, we plug in x plus h. And then we subtract f of x, so the original function, and then we divide by h, and I guess I actually forgot here to write down we have to take the limit, just get rid of that, we have to take the limit as h goes to 0. So let's just do that. Let's say, okay, that's the limit as h goes to 0, and I'm going to start with this part right here. Let me just change colour so you can see. I'm going to start with this right here. So I'm going to come up to my function, which is this right here, and I'm going to write that exact function, except every time I see x, I'm going to plug in x plus h. So that's 3 times x plus h squared minus 4 times x plus h. So now I've taken care of this part right here. Now I do minus whatever my function is, which is 3x squared minus 4x. And all of that is over h. And it's pretty ugly, and it's going to get uglier, but if you've done it right and set it up correctly, then things will start dropping out really easily. So that is the limit as h goes to 0 of 3 times, well, x plus h squared. Make sure you get this correct. That's x squared plus 2xh plus h squared. And I'm warning you, the thing that most people forget is that 2 right there. Then we've got minus 4x minus 4h minus 3x squared plus 4x. Another common mistake is people forget to distribute in that negative to that negative there. And all of this is over h. And one more line of ugliness and then it'll get very, very pretty. H goes to 0, so that's 3x squared, I'm just distributing the 3, plus 6xh plus 3h squared minus 4x minus 4h minus 3x squared, and then the 4x. And of course all of that's over h. Okay, what drops out? Hopefully lots of things are going to simplify now. Well, we've got 3x squared and negative 3x squared. We've got minus 4x and 4x. And I think that's everything. So now we're left with the limit as h goes to 0 of 6x h plus 3h squared minus 4h all over h. And of course there is an h in every term, so that is the vital part now, is that we can factor out an h in the top, and we're left with 6x plus 3h minus 4 all over h. Of course the h's divide out, and we're left with the limit as h goes to 0 of 6x plus 3h minus 4, which if we plug in h equals 0, which is what the limit tells us to do, we're left with 6x minus 4. And that is the derivative. Now, in this question they didn't ask you to do this, but what if way back here, when we started this question, what about if I said, can you find the derivative of this function, and they actually give you a point, let's say at the point 1, and I've got to work this out now, 1, negative 1. If they said, find the derivative at that point, 1, negative 1. So that would mean we come down here, and after we've taken our derivative, since they gave you the point 1, negative 1, all they're saying is this is x and this is y, so just plug in that x point. So that would be 6 times 1 minus 4, which is 2. Now, in this question I didn't ask you to do that, so your final answer is just 6x minus 4. But I'm just warning you that if they ask for you to do it at a point, that's what you have to do. So same question, find the derivative. Again, our derivative formula you are going to memorize is the limit as h goes to 0 of f of x plus h, so we're going to plug in x plus h, then we subtract f of x, and then we divide by h. So that's the limit as h goes to 0 of f of x plus h. So look at our f of x right here, and every time we see x, plug in x plus h. So that's x plus h plus 3. And then we do minus f of x, which is square root of x plus 3, divided by h. Now if we plugged in h equals 0 here, we'd get 0 over 0, and that would tell us nothing. So we're going to do our rationalizing trick, where we multiply by the conjugate, which in this case is x plus h plus 3 plus the opposite sign, x plus 3, and divided by the exact same thing. Almost seems pointless to do this, but you'll see that it helps us find our limit point. So now we're going to get limit as h goes to 0, and when we multiply them together we're going to get x plus h plus 3 minus x minus 3 all over h. And now that's going to simplify to, let's see, limit as h goes to 0. Well, the x's are going to cancel, the 3's are going to cancel. Oh, you know what? I forgot a whole piece of this here. Look at that. I forgot to write all of that in. So that's going to be square root of x plus h plus 3 plus square root of x plus 3. Man, I really nearly messed up that problem. So we're now left with the h on top, which, oh, h and h cancel, so that's 1 over all of that. And that's going to leave us with 1 over square root of x plus h plus 3 plus root of x plus 3. And as we plug in our limit point of h equals 0, that's just going to give us 1 divided by the square root of x plus 3 plus the square root of x plus 3. And the nicest way to write that is actually 1 over 2 square roots of x plus 3.